How y'all doing? Remember, we talked about derivatives today in class at any particular x value. How do we find the derivative of a function at any particular x, no matter if it's a given x or not? It's going to give you the slope of the line, the tangent line, in terms of x. So let's start off with a function, f of x. And let's let f of x equal 3x squared plus 1. Something simple. And I want to find a derivative of this function. That's the slope of any tangent line at any given point on this graph. So if I look at the points, remember, it's going to be some x value. So that x value is going to yield some y value, which we call f of x. So we're going to let this point be x sub 1, y sub 1. Good. So remember, we talked about some other point that's very, very close to this particular point. So the x value would be very, very close to this first point's x value, which we're calling x. So remember, we talked about letting h be something very, very small that I'm adding to x. So if it's something very, very small and I add it to x, x plus h would be something very, very close to x. So the y value of this particular point would be f of that x value, which we call it x plus h. So I'm going to call this point x sub 2, y sub 2. So remember, we said that when we find the slope represents the derivative. So we called it f prime at that x value, which we call in any given x, is going to be equal to the slope equation we know is the difference of the y's. That's y sub 2 minus y sub 1 over the difference of the x's, which is x sub 2 minus x sub 1. So the y sub 2 for this particular function is f of x plus h. Then minus y sub 1, which is f of x, all over x sub 2 minus x sub 1. X sub 2 is x plus h, and that's minus x sub 1, which we know is just x. So if I look at the bottom, like we said earlier today, that's a positive x and a negative x. Those two will simply cancel, right? So let me get my little eraser and just bloop. It's gone. So remember, we said h. H is that something that's very, very, very close to, it's something very, very small. So x plus h was something that's very, very close to x. So if I want something that's very, very small, I want this limit, the concept of limit, to let h go something that's very, very small, go to something that's very, very small, which we know is 0. So this particular equation that we set up, f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h, is the formal definition of what the derivative is. All right, so we have f of x. We said f of x was this good old equation here. F of x equal 3x squared plus 1. So let's go ahead and find the particular parts that we need to find. So let me go to a new page. I know, like I said, f of x is 3x squared, 3x squared, what it was, plus 1. Alright, plus 1. So if I want to find f of x plus h, everywhere I see an x, I'm going to plug in x plus h. So that's 3. Here's an x. So I'm going to plug in x plus h. And it's supposed to be squared. Then plus 1. So from algebra, we know when we're squaring a binomial, all we do is square the first term, square the last term, and the middle term would be the 2 multiplied together and doubled. So this becomes 3 open parentheses. The first term is x squared plus the double of the 2 multiplied to each other. That's 2xh plus the last term squared, h squared. Now let me put my plus 1. So of course I'm going to distribute this 3 in. So now I have 3x squared plus 6xh plus h squared plus 1. Alright, so let me go ahead and select that. This represents, of course, my f of x plus h. Why is it not letting me select it? Okay, I'm having technical difficulty. Y'all know how it is. And this steady just... Alright, whatever. It's not letting me select it, so we just gonna move on. So, of course, this represents f of x plus h. So if I could just go ahead and sneak this f of x plus h right here. Now remember, we were supposed to subtract f of x from it. That was the top part of that fraction that we had earlier, the slope equation. So I'm going to subtract what I had for f of x, which was 3x squared plus 1. So look, I have this 3x squared minus this 3x squared. So those will cancel, right? Then I have this positive 1 minus this positive 1. So those will cancel. So what am I left with? I'm left with the fact that f of x plus h minus f of x, remember that's what we were looking at, is equal to what was left over. We have 6xh and we have this plus h squared. Now remember, in the difference quotient, in that slope equation, we were dividing this by h. So if I divide this by h, of course I'm taking each one of these terms and taking away a h. So in that first term, I'm left with 6x, because I'm taking away one of them h's. Plus, if I have h squared, take away one of the h's, I'm left with just h. Now remember, I want this limit. I want that h to go to 0. So if I look at the limit as h goes to 0 of this function, 6x plus h, I'm simply letting h equal 0. So if I let h equal 0, I'm left with just 6x. So the derivative of the function that we had earlier, which was 3x squared plus 1, at any given point, the slope of the tangent line, which we know is the derivative, is equal to 6x.